Okay, today we're talking about inverse trig functions. Basically, an inverse function is when you have a function such as like y equals x squared. When I go to graph it, remember it was a parabola. Then we have this line right here called y equals x. And an inverse function is when it is reflected, this function is reflected across the line y equals x. So these two reflect, and then this will reflect. And so we have y equals the square root of x. So solving algebraically, we said y equals x squared. We switched those places, and then we took the square root of both sides, so that y was equal to plus or minus the square root of x. So y being equal to the square root of x, and this is y being equal to a negative square root of x. The reason it separates is because technically, according to the vertical line test, this would not be a function. So it would break up into one portion or the other, and so we would have a restriction. In this case, our y's would be restricted to those who are greater than 0, and then down here our y's would be restricted to those that are less than 0. Okay, so that's an inverse. It's a reflection over the y equals x line, and basically x and y switch place. So how that applies to sine, cosine, and tangent is very similar. If we go to graph the sine function, so we've got, here's our y-axis. Sine always started at 0, 0. Then it goes to pi over 2 and 1. And then it goes back to pi and 0. Then it goes down to a minimum of 3 pi over 2 and negative 1. Okay, then it goes back to 2 pi and 0. All right, so there's my sine function-ish. Now, if I were to write out my x and y table, then I would have, this is 0, 0, pi over 2 and 1, pi and 0, 3 pi over 2 and negative 1, 2 pi and 0. So my x's and then my y's. When it comes to the inverse right here, all of those are going to switch. In fact, this y-axis represents the values, and the x-axis represents the angles. And so the axes themselves will be switched. Okay, so this table, let's just sketch it really quick. X, y, we've got 0, 0, we've got pi over 2 and 1, we've got pi and 0, 3 pi over 2, negative 1, and then 2 pi and 0. For cosine, we've got, there's my y-axis, represents values. This represents angles. Okay, we always start at a maximum, so this will be 0 and 1. Then we go to pi over 2 and 0. Then we go to pi and negative 1. We go to 3 pi over 2 and 0, and then back to 2 pi. All right, if I make a table of values there, I've got 0 and 1, I have pi over 2 and 0, pi, negative 1, 3 pi over 2, 0, and 2 pi is 1. For tangent, which is what we've been doing, here's my y-axis. Recall that tangent, the heart and the center is right there at the origin, 0, 0. 2 quarter periods to the right is an asymptote. 2 quarter periods to the left is an asymptote. That's going to be at positive pi over 2. This is going to be at negative pi over 2. Here's going to be pi over 4, and this is negative pi over 4. At positive pi over 4, we have a value of 1. at negative pi over 4, we have a value of negative 1. So here was our tangent function. So we have x, y. X, when x is negative pi over 2, it's undefined. At negative pi over 4, it's negative 1, 0, 0. Positive pi over 4 is 1, and positive pi over 2 is undefined again. Okay, so it says all three graphs are not one-to-one, so their domains must be restricted. To find an inverse that is a function, so remember, it always has to pass the vertical line test. The function arcsine, so y equals arcsine, if and only if the sine of y is equal to x. Okay, the domain here is going to be from negative 1 to 1. So again, right here, our domain for sine was negative infinity to positive infinity, and our range here was negative 1 to 1. So in an inverse function, the domain and range switch places. So it makes sense that our domain is now what our range used to be. What doesn't make so much sense is that the range of this arcsine is from negative pi over 2 to positive pi over 2. So we'll look at the graph to get that information. Arc cosine, if and only if, y equals arc cosine of x, if and only if cosine of y is equal to x. Again, our domain here is going to be all reals, but our range is restricted to negative 1 and 1, and with an inverse, those switch. So we understand the domain is basically restricted by the range of the original. But a question is how and why is it just from 0 to pi for the range? Arctangent, okay, so our domain here is restricted by the asymptotes. So from negative pi over 2 to positive pi over 2, and our range here is actually all reals. So it can go forever. So when these switch places for an inverse, that also makes sense. And this is restricted by the asymptotes. So that makes sense as well. So everything's restricted to just this window. Now an inverse, again, it's almost like you take the original, and again, you're reflecting it over this y value. So what used to point up is now going to point to the right. If it pointed down, it would point to the left. So when I go to graph sine and cosine right here, the arc sine, arc cosine, let's think about this. We need values that are from negative 1 to 1. So when is the sine value negative 1? Well, we would say it's 3 pi over 2. Well, isn't 3 pi over 2 the same as negative pi over 2? Okay, and when is the sine value positive 1? Well, that's at pi over 2. So that's where we get our range from. If we look at the unit circle here, going two quadrants 1 and 4, will give me all the possible values for y's. So from negative pi over 2 to positive pi over 2. So on my y-axis now, which is now going to be my angles, because remember the axes switch, and so this will be my values. My range of values are really from negative 1 to positive 1. That's my domain. Okay. This right here is the angle 0, and so down here will be negative pi over 2, and this will be a positive pi over 2. So this is going to be my maximum. Sorry, I did not mean to put a point there. Will occur at pi over 2. The max will occur at pi over 2, and the minimum will occur at negative pi over 2. So the maximum of 1 is at pi over 2, 0, 0, and the minimum will occur here. And so my arc sine function will look like that, restricted. So it doesn't go on forever. It stops right there at that point. It stops here. And these are all the values that I can basically get out of the inverse sine or the arc sine. Cosine. Okay, so when is the cosine value -1? Okay, the cosine value is -1 at pi. When is the cosine value 1? Well, that's at 0. But when we write a range or a domain, we always do the lesser first. So that's where 0 and pi come from. Okay, so here's my angles. Here's my values. Minimum value is -1, maximum value is +1. Okay, at an angle of 0, I'm going to be at 1. Okay, at an angle of pi, so let's say this is pi, I'll be at -1. Okay, and then pi over 2 is right here, and it will be 0. Okay, so we'll have cosine value, arc cosine, that looks like this. And of course, there's all these other little values in here. But this takes care of all of those actual values from -1 to 1. And it still follows the vertical line test, making it a function. Okay, arctangent, or tangent to the -1. Our range is going to be restricted. So here's my angles. And so at pi over 2, there's going to be an asymptote. Hold on. Okay, and then at pi, -pi over 2, so here's my x-axis there, there's another asymptote. And remember, tangent was always centered, so if I go back up here, when the angle is 0, the value is 0. So we want a value of 0, and the angle is 0. And then this angle is going to be pi over 4, and this will be a -pi over 4. And so that's -1, that's 1. When the angle's pi over 4, the tangent value is actually 1. When the angle's -pi over 4, the tangent value is -1. So here's my tangent function, arctangent function. And so here we definitely see that the domain is all real numbers, that the range is restricted to this asymptote. Okay, so what does that mean? Well, that means that right here, arc sine is restricted to quadrants 1 and quadrant 4. Okay, arc cosine is restricted to quadrant 1 and quadrant 2. Tangent is restricted to quadrant 1 and quadrant 4. Anything with a y is an odd function, therefore it's going to be up and low, up and down, up and down. And for cosine, it's basically just the top hemisphere of the circle, or semicircle. Okay, next page. So basically, when you have these that you're evaluating, it's telling you that you have, basically, we need the tangent of what angle is equal to 1. And so then we'd say, okay, that angle's pi over 4. That's what you're doing every time. The cosine of what angle is equal to the square root of 2 over 2. And so we're trying to find that angle every time it gives us this value. Down here, sometimes these ratios are not unit circle ratios. If that happens, then I can actually draw a triangle. So this arc sine right here is telling me the same thing up here. I can either find the angle and then take the tangent, or I can use this ratio to set up a triangle. Sine is opposite over hypotenuse, so I can draw this triangle right here. The opposite is 3, the hypotenuse is 5.